and then one B question with 4 parts. So it's like 8 questions.
What is
B question is about no. So that's good news, right?
No. Because you say projectile now.
Oh yeah, I said projectiles is in the exam, and it is in section A.
But you should pay more attention to projectile.
What?
You said this.
But section B question is so
I
easy.
think maybe you put the projectile in section B.
No, sorry.
No.
Section B is about Newton.
Wow.
No, you said you were going to put projectile question for section B.
I never.
You did, I wrote it down.
Yeah.
No.
Bonus mark, yay.
Right, fine. So you can call this section A, answered 4 parts, and then you can call this section B. Whatever. Alright, sorry. I didn't think I said that.
Okay.
If you watch the video, tell me the time in the video I said that.
I will.
No, really.
I will.
My mind, I don't remember that, but whatever. Okay, did you look at that animation I asked you to look at?
No.
What animation?
Oh, dude, I only gave you one homework to do.
What's the video about?
Look at it tonight.
Wait,
Is it interesting?
I think so.
Which one?
Something
I'll show you now. Hang on, let me just get to the slide we were on. I asked you to look at this.
Train.
Oh, oops.
Something about train.
Yeah. Will you look at it tonight, please? Will you?
Mm-hmm.
Will you? Maybe. That's an honest answer.
I
Thank
will.
you. All right, we'll continue where we left off then. So we're on to this slide. So some definitions of words.
Is this in the test? No.
No.
Good.
Good news indeed, yes. Okay, so equilibrium, or origin, that is where the center of the motion is. So if you look, if the spring is going like this, the origin or the equilibrium is in the middle, where it's moving around. Okay, so that's called the equilibrium or the origin, is the center. Yeah? Okie dokie. Does anyone know this word, amplitude?
The loudness.
Yeah, well, no. So with the spring, it's going like this. Look, it's going like this, yeah? The amplitude is the maximum distance from the center. So this is the amplitude. Do you understand? Yes? Grace? From middle to highest is amplitude.
I know, like it could be negative, positive.
We usually choose the positive value. Yeah. Although technically it could be negative, I guess, but well, we usually use positive. Got that? You all know velocity. And you all know angular frequency from circular motion. You all know frequency. You all know periodic time. So these are the words we use.
Can you explain angular frequency in a line?
That's what the animation was for. So if you watch the animation, it might help. Yeah? Alright. Now, when it's like the spring going up and down, when it's at its maximum displacement, it's not moving. Oh my goodness Grace, who are you talking to?
Somebody.
Push the phone away, please. Thank you. So when it's going like this, when it's at the highest, that's when it's not moving. Because it goes up, slow, stop, and then comes back down. So at the maximum, it's at rest. Yeah? So it has no kinetic energy here, and has no kinetic energy here. Where does it have most kinetic energy? In the middle. So it goes really fast, and then slow, and then really fast. So in the middle is when it has most kinetic energy. Yeah? Question?
Why?
At the top, it's not moving. Because it goes like this. Slow, 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 stop. Fast, faster, faster. Fastest. Slower, 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 stop. So, in the middle is maximum kinetic energy. Is when it's going fastest. Potential energy is maximum up here. Because all the kinetic energy here becomes potential energy here.
Yes.
Yeah? So, as it starts to move, its potential energy becomes kinetic energy. When it's at the origin, here, no potential energy. Only kinetic. This is when it's traveling the fastest. So, what you don't need to write this down if you don't want to, but what you do need is the graph of the energy. Oh, that's tiny. Oh, so sorry. Oh, rats. I'll make it bigger in this. I think. So this graph here we go. Okay. So can you see this one is the potential energy? When it's away from the origin, it has most potential energy, and then when it's at the origin, it has no potential energy. Then when it's under the origin, it gets more potential energy. The kinetic energy is 0 at the highest and at the lowest. And when is the kinetic energy the highest? When's the kinetic energy? In the middle. Okay, so they ask you to draw this graph in the exam sometime. So please draw this graph. Can I do what? Zoom in.
Energy. Just I want to write down the sentence.
Are you going to go back?
Yeah.
To this? Which sentence do you want?
Just write down.
Okay. Okay. I don't need to write all of this down, Amanda. Okay. I think the graph is what's most important. Okay. So, what? What do you don't? Oh. I care about this graph.
Yeah, I didn't.
Yeah, so the total energy of the kinetic plus the potential, you can see it's constant, as it should be. Ah, yeah. Right. This is what you need for the exam.
This exam.
No, the end of the semester exam. Okay, can I continue? Continue, Amanda?
Yes.
Okay. Right. So So you don't need these graphs because we kind of saw it already. But the displacement, it goes up and down, up and down. The velocity also goes up and down, up and down. And you're not surprised to know the acceleration goes up and down as well. Do these graphs look familiar? Have you seen any graph like this in maths?
Wave.
Yeah, what?
Sine?
It looks like sine and cos,
Yes.
doesn't it?
Mm-hmm.
So, when I give you the formulas, you won't be shocked if there's a sine or a cos in the formula. So here are your formulas for simple harmonic motion. Yep. So, the first formula, have you seen this before?
No.
Yeah. Second formula, have you seen this before?
No.
Yeah. Third formula is now new. The S is the distance from the origin. So here, going up and down, the S is the distance from the origin.
Acceleration?
And this is the formula for acceleration. Mm-hmm. Now, in this formula, the S is A cos omega time. But that's only if it starts in the middle and goes up and down. If it starts in the middle, we use this formula. But if it starts at the top, well, I'll wait till you have it. Well, can you just wait and just listen before you write this down? Look at me. Yeah. So, there's two situations. It starts in the middle and goes up, down, beginning in the middle. That's cos. But if you start at the top, or if you start at the bottom, you should use sine. So if you start here and go down, up, then you use sine. No. I said this.
That way around.
Blast it! I have it exactly backwards. Sorry, it's completely backwards. I remember I made this mistake last time and I forgot to change it. Yeah. The cos should be a sine and the sine should be a cos in the formula here.
You said you should change it later.
And I forgot.
From last year.
Yes, exactly. Right, so sine should be a cos and cos should be a sine. And the sine should be a cos and the cos should be a sine. So if you write this down, when you see cos, write sine, and when you see sine, write cos. I'm so sorry. So if it starts from the middle, use sine. Yeah, I didn't change it. And if it starts at the top, use cos.
So what do we write? Cos or sine?
So just literally replace the word cos with sine and replace sine with cos. I have it backwards. Okay, did you fix that? Next formula. Again, replace. The velocity is A omega cos omega t. Otherwise, it's sine. So, sorry, again, this should say A omega cos omega t for velocity. What's wrong, Amanda? This should say, Amanda, this should say cos, and this should say sine, yeah.
What do you say on the top?
Equilibrium is the middle, the origin. Continue? Yeah. The next, crashed. Okay. We were around about here. There we go. I fixed it in this one. Okay. The next formula is another formula for acceleration is equal to this. And the last one is the formula for potential energy.
Will this formula be given in the paper?
Yes. Interestingly, formulas 1 to 6 are in the formula book, but I don't think 7 is.
And what does A mean in 7? Acceleration?
In 6,
Yeah.
big A is the amplitude.
Why they don't give all the formulas?
I don't know. I really don't. I think it's because the person who makes the book forgets to include it.
Maybe you should, maybe forget that.
Well, if I made the formula book, I would include all the formulas because then I could change it each year if I forget one. But I have to use the formula book they give me, so I can't change it. You got these? Yeah?
Can I write some formula on the formula?
No, you can't. Continue?
Yeah.
In the real world, though, doesn't really happen. You have something called dampening, as you know. So, like if you have a spring, it doesn't go like this. What will happen? It'll go like this. But we don't look at that in this course. It's too advanced. But if you want some English, this is called damping. Just the word is enough. Okay? Continue? Oh, yes. I couldn't find a picture for this. Even though I searched and searched, I couldn't find a picture. So I have to draw this one. This is the name of it. You can write it in a minute. But what happens is, you have a person here and a spring here, and this spring is going up and down. Yeah? And then he is also moving his hand up and down. So yeah, he's going like this, and the spring is going up and down like this. Yeah, like a slinky or something, yeah. And he's going like this, and the spring is going up and down as well.
Is that a weight at the bottom?
Yeah, a weight. Now he doesn't need to move his hand. If he kept his hand still, and then you just pull this down and let go, what would happen? It would still go up and down. But he also shakes it. So here we'll say this is omega 1, and this here is omega 2, and then he has an amplitude, so we'll call that A2, and this has an amplitude, we'll call it A1, and this has a time, we'll call it T2, and this has a time, we'll call it T1. My question is, my question is, if he wants to make this amplitude bigger, which thing should he change here? So look, you've got two simple harmonic motions. Simple harmonic motion of his hand, and then simple harmonic motion of the ball. So if he wants to make this bigger, which of the three things should he change, do you think?
The A.
Oh well, you could also have frequency too if you want.
Change the A.
Change the frequency.
Let's just keep it to these three first. So you're saying you should change the A. So should he make it bigger or smaller?
Bigger.
So you're saying that if his A2, he makes it bigger, then the A1 should get bigger as well. Okay? Any other opinions? No? You agree or disagree? A here?
Yeah.
is amplitude.
Oh.
A minus A. So you're saying amplitude. If he makes his amplitude bigger, it will make this one bigger. Yeah. No. No.
Maybe it's
You think he should shake it faster.
Yeah.
So he should make this T here smaller.
Mhm.
So if he makes this smaller, it will shake more. No.
No, because that's inertia, so it will.
No.
It's in motion because you
Is it the W?
The omega? Yeah. Should he make it bigger or smaller?
Bigger. I think bigger the better.
Yeah. No. This is the thing. If you want this to shake harder, you don't change this, you don't change this, you change this. Well, you could change this because you can relate them with the same formula. What you need to do is to make omega 2 be the same as omega 1, or T2 to be the same as T1. When he is vibrating with the same frequency here, its amplitude will be greater.
It's like the resonance form.
That is what this is. Omega? This? No. No, omega is 2 pi over T. Omega, not W. This is W.
Yes, the V for Greek language.
I think so. What's wrong?
I forget what this one is the name.
Then you need to watch the circle lesson again. Watch the lesson again. Continue.
No.
Make it happier?
Faster. Yep, bigger omega makes it faster. Because also, Grace, V equals omega or. So if the omega is bigger, the V is bigger. Continue.
Do we get this from the formula?
Continue. No, okay. Well, my picture, yes, it's great. Did you get the name of this though? No. So this is called a, not quite, forced harmonic oscillator. Do you have the picture? Yeah. So this is called a forced harmonic oscillator. I thought you say forced. Forced. Yeah.
It's like the swing sometimes, like this, you push it in.
Yeah. Although the force is always on it, continuously. Yeah. Yeah. Continue. Right. So look, I know we need to be starting the test. So let me see. There's 2 questions to do, but I don't have time to do them now. So, well, I mean, you can definitely try the homework because you have the formulas. But if you can't do it, that's okay. We'll do it next time, the examples. Okay, hold on there. Look, leave Sophie alone. What are you getting her to do? Take pictures for you?
Yes.
But you know, after this lesson, the video goes on YouTube. So you could watch the video and then pause on this picture.
We're lazy to open the laptop.
But if you should type it, I don't want to
Yeah, so, yeah, you don't like moving or doing things.
Yeah.
Alright.
Want to stay at home.
Yeah, me too.
Want to go home
No,
now.
no.
Cancel afternoon.
Cancel the day, yeah. Okay,